Okay, so what we're going to do today is that I'm going to go over a review of midterm. Now, under Canvas, there is a exam under files. You will see that there's an exam folder that is now published. And under the midterm section of, let me double check that. And on as I'm talking, and under the midterm section of that, you would basically see that there is a sample midterm, there is the midterm review, and then there is a study guide. So I will go over all of this. I will see if I can finish the sample midterm fully, but we'll try to cover as much as we can today. So I'll start with the midterm review slides, basically covering or doing a quick just revisiting of whatever we have talked about, and what kind of or what type of questions you might expect in the exam itself. So we'll go over that midterm review. I will go over these slides, and then we will move on to the study guide, and then finally the sample. So that's the overall plan for the day, and I have the session recorded. So if anyone hasn't joined, which I understand, they can review these slides and this recording after. So what are the topics? Let's get started with that. Basically, the topics that are going to be in the exam or midterm exam are going to be whatever we have discussed from the very beginning of the class, session number 1, all the way to this last yesterday's session. So even if there is something that is not here on the slides or the study guide, it will be covered. Okay, so whatever we have talked about. So the topics, right? At the beginning of the session, we've started talking about database management system. And as part of that particular discussion, I did talk about, the definitions. What is, let's say, a database versus a DBMS? And why would we need to have a DBMS and a database? We did talk about, at the high level, the architecture of a DBMS, the components that are included, again, high level, in a DBMS. So we know that there is a query processing, we know that there is an optimizer, we know that there is a file and access method, we know that there's a buffer management, we know that there is a catalog database, right? All of that we've talked about. We know that there is a catalog database whose job of this catalog database is to store metadata about the files that this particular database is storing, right? This DBMS is storing, and those files are basically related to your databases. We did say a database is collection of files, right? So if I have a database that contains, for example, student records, student taking courses and professors teaching courses and so on, that database that contains those tables, right, is associated with a set of files, right? So those files will be stored in the file system of your DBMS, and DBMS has this catalog database, right, itself, that has the metadata corresponding to those files, where these files are being stored, what is the size of the files, what is the name of the file. So for example, corresponding to the student table, we may have 1, 2, 3, 4 files associated with that. Okay, where are they being stored, and so on. So when you, in fact, dispatch a query, right, which you now have been doing, right? You just finished your homework number 3. So now you guys are expert in writing queries now, as far as I'm concerned. So in that case, then what will happen is that when you go ahead and submit the query to your DBMS checks it for syntax issues and so on. And then once your query is a valid query, right, it will go ahead and attempts to fetch those files, those tables that your query needs to operate on. Let's say, for example, your query is going to be operated on students, on sailors and reserves and boats. These tables have to be fetched, right? So then it will go ahead and consult this catalog database. Again, it says, okay, what are the files associated with sailors table? Okay, it says this and this and this files, and then they're stored in this particular location. These are the name of these files. So those files will be opened, right? The content will be fetched. The fetching has to, then it will be done using the buffer management component. So we've talked about that. And then we've basically stated that, well, do we really need a DBMS or not? And maybe I'm a very good programmer, okay, that I can like really write code very quickly on the fly, right? How about I'm just going to go ahead and use a flat file solution and then have a students.txt, professors.txt, takes.txt instead of having a DBMS. And then I'm just going to write these, CRUD operations. And then we've gone through that and said that's actually not an optimal solution. And there are benefits of using DBMS. We've talked about that in detail: scalability, efficiency, concurrency, crash recovery, transactions, and so on. Okay, so take that into account. We've talked about that, right? We've talked about the 3-level architectures, right? Use, logical, physical, right? We've talked about transactions. We talked about asset properties, right? That we've talked about, right? So in the case of asset properties, right, we've talked about the fact that there is atomicity, consistency, isolation, durability, right? And you need to basically know, at least from a conceptual perspective, what a transaction is, what an asset property is, and so on. So from chapter 1, which is a database management system, almost all the questions would be conceptual questions. And the way it would be covered in the exam, okay, it will be over true-false questions, multiple choice questions, or short answer type question. Okay. Again, a type of a question that I may ask. Okay, I may ask in a multiple choice type fashion. Okay, what is a transaction? Okay, or I may ask in a short answer type fashion. Hey, describe asset properties. Okay, and so on, or true-false. Then we move on to entity relationship. So that's another discussion we've had in the course. As part of the entity relationship model, what we did is that we've talked about more or less the conceptual database design. Okay, and as part of the conceptual database design, we've discussed notation to represent your set of requirements using the ER model. Okay, the notation was that, hey, you need to have a rectangle for an entity, an oval, right, or ellipse for attributes, and then a diamond for relationship. Now, we did talk about different types of attributes. We talked about derived attributes. We've talked about composite attributes, right? And so on. So we did talk about different types of attributes and how we could represent them. We did talk about different types of constraints, like key constraints. A key constraint is like multiplicity or cardinality, 1 to 1, 1 to many, many to 1, many to many. We've talked about participation constraints, what is a total participation versus a partial participation, and how you would go about representing these type of constraints on your ER diagram. So for example, for the key constraint, we did say that you will add an arrow that points to, let's say, the direction of that particular, let's say, entity that one refers to. Okay, or for the participation constraints, we did say for the total participation, we make that line bold, right? That also we've said. We did talk about the design choices that you guys may need to be having, like entity versus attributes or entity versus relationships and so on. So we did talk about the scenario that we've talked about was that of, let's say, a student having a phone number or an address, okay? And we did basically said that this phone or address is a property that we need to go about representing, and how about representing it either as an entity or attribute. I mean, whether I should have an address or phone entity, or I should have it as attribute. And then it all boils down to the requirements, right? The set of requirements and use cases that you have, okay? So we've looked at, multiple cases of designing and design choices of representing that property, address versus phone, using entity versus attribute. And then we've considered different type of requirement. So for example, in a case where, you may have multiple addresses and so on, then we said, okay, maybe a entity representation would be a better choice. So we also did talk about extended ER. Okay, and as part of the extended ER, we've expanded our representation to include objects and inheritance relationship. We've basically stated that as part of the extended ER, we have the concepts of generalization class versus specialization class. Generalization class is my superclass, specialization is subclass, right? So that means that the specialization, the subclass, will inherit, right, all the generalization attributes of the superclass, okay, as well as the relation. So we've talked about that. The relationship, and this is a question that was being asked as you guys were working on your homework number 1. Should I add a relationship between the subclass and superclass? And the answer would at that time was no, and the answer is still no. The relationship between subclass and superclass is the inheritance relation. Okay, you're not going to have any other relationship between the two. The only relationship between the superclass and subclass is inheritance, okay, which we are representing using EER, extended ER. And then for that particular relationship, which is the inheritance, we did say that we have constraints. The constraints we've talked about again was total versus partial participation. In that case, we will have a double line, okay, or disjoint versus overlap, where in the circle we will put D versus O. So that also we've talked about. Now, the type of questions you may get here. You may be given a scenario. The scenario, and this is something that is there in your sample midterm also, which we will go over. The scenario is much smaller and much more contained compared to your homework number 1. So definitely go ahead and revisit your homework number 1. But I just wanted to make it clear that you're not going to get, a similar scenario like homework number 1, much smaller. Okay, it will have a few, let's say, entities and relationships, and the goal is to make sure that you guys have understood these concepts of representing entities versus relationships, right? Entities and relationships, and you have understood how to make these design choices, and you have understood how to go ahead and represent these constraints, key constraints, participation constraints, and so on. So you will produce an ER or EER based on that particular given scenario. Again, it's very small. It would be contained, and then you guys can either use your tool of choice. I mean, you can use the same tool that you have used in your homework number 1. And of course, I will take the time that it takes for you to go ahead and design this in consideration. Either you can use a tool of choice, where it could be MySQL Workbench. Some people use Word, some people use Visio, okay, and so on. So whatever tools you have used, or you can simply draw it on a piece of paper, right? Take a picture of that using your phone, and then I will have for that particular question a file upload option, which you can go ahead and upload that into. I am not going to have lockdown browsers, okay, lockdown browser for the midterm, right? So that I'm not going to have that. I know that we have it for the quizzes, but given that we may have to have file upload options and you guys may need to have these tools, I'm not going to require lockdown for the midterm. Okay, so file upload option will be there. As long as I get basically the ER diagram, either through a tool or even handwritten, but if you do it handwritten, make sure it's legible. Take a picture of it and then submit that, okay, to the file upload option. Okay, any questions so far? Any questions? Questions so far? Yes, you have to be on Zoom. You have to be on Zoom. I will take attendance over Zoom, so everyone must be on Zoom, okay, for the duration of the exam, okay, and it's there in the study guide, okay. Everyone must be on Zoom and with camera on, okay, so take that into account. Camera also should be on. Now that I'm not requiring lockdown, everyone has to be on Zoom with camera on, and then I will record the session. Take that into account, which you can do it on the same device, by the way. Any other questions on that? Okay, so you guys will be producing this EER based on a given scenario file upload option, right? Here are the things that you must consider. You will have to use the connotation discussed in our class, okay? Rectangle for entities, ovals or ellipses for attributes, different type of attributes. We've talked about how to represent them. Arrow for discussing key constraints, one-to-one, one-to-many, many-to-one, many-to-many. Participation constraints, total versus partial, bold line, and so on. So again, make sure that you use the notation discussed in the class. And it is extremely important to identify all the constraints, key constraints, participation constraints. You identify weak entity, in this case, weak entity sets, okay? The weak entity set must be in bold, okay? Weak entity set. Relationship connecting to the identifying owner must be bold, okay? So the weak entity itself must be bold. Relationship connecting to the identifying owner must be bold. You must identify a partial key, okay, for the weak entity set. It will be dashed underline. Weak entity has to be in total participation with the identifying owner and in one-to-many relationship, okay? So all of these has to be identified for a weak entity. Take that into account. Now, when you're representing your ER or ER attribute types, okay, make sure that they are properly mapped, okay? Whether you have a single attribute, a composite attribute, or derived attribute, they have to be clear on your ER or ER diagram. Primary keys has to be indicated, solid underline, okay? That's a primary key. So these are the things that I will be looking for. Any of them missing, there will be a point deduction corresponding to that. So take that into account. Any of these missing, point deduction. Similar to your homework number 1. So point deduction. If you, let's say, for example, have a weak entity and then you forgot to make it bold, that's basically a strong entity. You will have a point deduction. If you forget to identify a partial key for your weak entity, point deduction, okay, and so on. So take that into account. All of these I will be looking for, okay. Notation, proper notation, identifying constraints, key constraints versus participation constraint, weak entity versus strong entity, right? Weak entity itself should be in bold. Relationship connecting it to identifying owner must be bold. Partial key must be properly specified, okay, dashed, underlined. Weak entity has to be in total participation with the identifying or any one-to-many relationship. Different types of attributes properly mapped, okay, and primary key, solid, underlined. So I will be looking at all of these things. You get the scenario, you map it, you got to make sure that all these things are mapped properly. Okay, that's one question which you will get. You will definitely get a question, okay, on this one. So go ahead, and there are exercises that I have already posted. There is your homework number 1. There is again on the back of the chapters of the book, more exercises with the solution also given by the authors of the book as well. Okay, so take that into account. And I can also post that solution, meaning post a link to it as an announcement. So there's no question of where to find it and so on. So I will do that right after this session. You will get a question on that. You will get a question definitely on conceptual aspects of the course, true, false, multiple choice, short answers. So far, 2 questions. Then you will have relational model. Now, for the case of relational model, give me one moment. For the case of relational model, 1 second. There it is. Okay, now let's move on to relational model. So you have in, let's say, one of the questions, you have produce your ER or ER, and then you will be asked, or you may be asked, to map that particular schema. It could be that schema that you guys have created as part of the question asked earlier, or I may give you a new ER diagram and I may ask you guys to map it, okay, to a schema. Okay, I may do that. That mapping from conceptual database design, logical database designs, I will ask you guys. Okay, so as part of the relational model, what did we talk about? We also had homework on this. We've talked about relations, instance table, schema, row and tuples, right? What is a relation? Relation is a basically mechanism that we use to organize our data in the form of relations, tables, right? And tables contains rows and columns. Okay, rows and tuples are our records. The columns are the attributes, fields. Okay, so the mechanism that we organize our data in a relational model is using relations or tables. Okay, and then for us, in order to be defining them, we use the schema notation, which we've talked about. Schema has a name. Okay, schema has a name, and then each of those attributes or fields along with their data types or domain. Okay, primary key will be underlined in the schema, and then foreign keys, which are like pointers, will be identified using that line that we had in your homework number 2. Okay, you could also map that properly. You can identify the primary keys as well as the foreign keys. We've talked about keys in general. We've talked about super keys, primary keys, and candidates, right? We basically said that super key is basically an attribute or set of attributes that collectively uniquely identify a particular record. And we said candidate key is a minimal super key. It's basically a key that has less number of attributes than the super key, okay, which can uniquely identify a record. That's a candidate key. Now, again, I did say that you may have multiple candidate keys, right? In the case of a vehicle, we did say that one candidate key that you could have is a VIN, or another candidate key that you have, it may be, let's say, for example, state plus license, okay, or license, right? So these could be different type of candidates. So it's then our job as a database designer to go about picking one of these as the prime, okay? And that's the key that will be underlined. So primary key is basically one of those candidate keys. That's the primary key. So a primary key is a candidate key, okay? But not all candidate keys are primary keys. Take that into account because you may have more than one case. We've talked about integrity constraints. Integrity constraints, the primary key, basically is the primary key constraints. Referential integrity or foreign key constraint, as well as the domain constraint. So again, when you guys are going in and mapping your databases, okay, your ER diagram to a relational model, integrity constraint must be identified, okay, in your schema. Now, the question that I may give here, okay, is that, as I did say, I may ask you guys to produce a schema for the ER that you have created as part of the previous question, or I may give you a new ER of my own, right? And say, hey, you go about reducing this into schema. Now for the schema, I may ask you to just go ahead and produce the schema without giving me SQL, or I may ask you to provide the schema as well as the SQL DTL statements, meaning create table statements. Okay, both of these may be asked. Either could be a schema itself, that means that you just define the schema for the tables, or I may ask you for create table statements, or both of them, schema plus create table statements. So that depends on the question that I will do. Any questions on this one? Okay. Now someone asked how many questions you should expect. About 15 or 16 questions, but 15 or 16 questions that would basically take into account all those individual, let's say true, false, multiple choice, short answer type questions. Okay. So yeah, 15 or 16 type questions, including, you know, all those individualized true, false, multiple choice, and short answer type questions. You may have individual, let's say, SQL queries to write and so on. Any question on this one? Relational model. Okay. Another question. So you will definitely get a question on the relational model. Same flow that we've gone over in the class, you will also see it in the exam. Okay. Conceptual database design, then we will map it to logical database design. Okay. Once you map it to logical database design, then we will go ahead and start looking at SQL queries. Look at SQL queries. So either using the scenario that you guys have mapped to a relational model, or with a new schema, I may be asked to write several SQL queries. Okay. Again, that will be similar to your homework number 3. So again, it will be less involved compared to homework number 3. Okay, it's an exam, so we have much more limited time. It will be less involved. You guys will get a series of questions, and you guys will have to basically write SQL queries. Select from where, okay, group by having, okay, and then don't forget the aggregate functions or operators: count, sum, average, min, and max. Make sure or take into account integrity constraints, table constraints, domain constraints, foreign key constraints. Right? We've talked about table constraints, right? Check condition, right? We've talked about, you know, unique versus primary keys. We've talked about not null and so on. Okay, take those into account. We've talked about how to create views, how to store, let's say, the result of a query. We've talked about how to create assertions. We've talked about triggers, SQL triggers. Okay, and we've also talked about handling nulls. Okay, if in cases where you have nulls in your tables, how you would go about handling nulls. So we've talked about all of that. Now, with regards to the SQL queries, right? With regard to the SQL queries, few things to take into account. First of all, for the queries, I may be very prescriptive in terms of telling you guys how to write a query. I may ask you specifically to write a query in such a fashion. I may ask you to use union, intersect, or except. I may ask you to use nested queries and use, for example, in or not in keyword. I may ask you to use exist or not exist keyword. Okay, I may ask you to use certain aggregate operators and so on. So I may be very prescriptive in terms of how I want to write your. So it is very important for you guys to go ahead and revisit all different ways of writing a query. Okay, you're not going to say, oh, I know how to write it this way, and I'm going to write every query this way, and I'm just going to skip all those, and I'm not going to go study them. No, because that may be the case. I may, for some of the queries that are in the exam, I may ask you guys to specifically write it using a particular mechanism that we have talked about in class. Okay, so take that into account. Or I may ask you to I may not be prescriptive, okay, and I may just give you the statement related to the query itself and ask you guys to write it. And in that case, if I leave it open, then you have to take into account yourself multiple ways of writing a particular query and give me a better, more optimal solution. Okay, so for example, if let's say I ask you to write a query and then you go ahead and join 3 tables, which we've discussed in the class, and then you only needed 2 tables, you will get a point deduction, okay? Because your query is not that efficient, okay? So you just go ahead and blindly join all tables that are given in that question, right? Or let's say if there was a solution with a nested query that is more optimal compared to like joining them, then I expect you to pick the more optimized mechanism to write the query. Also in the exam, it is possible that you get a mixture of this. For example, let's say you have 5 or 6 queries to write. Some of them would be very prescriptive, some of them would not, okay? The very prescriptive one that you have to write it in that exact mechanism I'm asking you, the ones that are open, meaning that I did not tell you how to write it, then again, you have to take into account how to write, the more optimal way of writing that particular query. So I want to see for those type of questions, how you could, decide in terms of the type of queries or the best mechanism to write that particular query itself. There could be 5 or 6 queries to write, okay? And these could be in different, let's say, complexities. There definitely would be some simpler ones, there would be some medium ones, there will be more complex ones. So obviously there will be a mix and match. But take into account when you write these queries, you may have to handle nulls. Okay, very important, because you may have situations where you may have null in your data. Sometimes students write queries, but then they forget about thinking about null situations. Okay? Or for example, they would write, and we had that scenario in the class, they would write, for example, a query using intersection, and then they forgot the fact that, hey, we may have names, and these names might be the same, but their IDs might be different. So take that into account as well. These are small things that could come in, but we have discussed them. Okay, but you need to take them into account as part of the question itself. So 5, 6 queries you will have to write, plus conceptual evaluation strategy. In this case, I may give you guys a query, okay? And I may ask you, what does this query does? And then evaluate it, So in that particular query, you have to tell me what the result of that query would look like. Question on this one? Any questions? Okay. Now, back on the relational model, to expand on that, which we did talk about, right? I did say that you need to map the produce EER to a set of relations. Okay, SQL may be required. I may ask you to just, define just a schema, or I may ask you to write both a schema and SQL, meaning that have create table statements. Make sure you have the proper table constraints, okay? Then the requirements. If an attribute is not null, make sure you specify that. If an attribute is primary key, you specify that, right? And so on. Foreign key constraint, 100% must be specified, plus their actions, no action, cascade, set default, set null. Don't forget about those. If the question, okay, is not asking for SQL, if I'm asking you only for defining the schema, then you will have to define the schema using the notation discussed in the class and use for homework number 2, right? Schema name, and then in parentheses, you will have the attributes and their domains, primary key underlined, okay? That's identify the primary key. And foreign keys, you will define them using having a line, pointing like a pointer, pointing from the primary key, from the foreign key to the primary key of that particular, let's say. So make sure you use the notation. Or I may have both. I may ask you guys to have the schema as well as SQL. So that's for the relational model. So again, these are the points that I will be looking at. If I ask you for SQL, then your create table statement must include table constraints. It must include foreign key constraints plus their actions. It must include that. No, none of those. If you just give me creates the table statements without any table constraints, without any foreign key constraints, there will be a point deduction. Okay. For the case of SQL, I did talk about that. Okay. If I did ask you guys to tell me what the query does, tell me what the query does in simple English. Okay. If I did ask you to explain the query, then you have to explain. You can explain step by step what the query does. Okay. So if I'm asking you what the query does, maybe you give me one line in terms of, okay, what does this query do? If I ask you to explain it, then you will go through what the query does and then explain it line by line. Oh yeah, I'm joining this table and I'm excluding this, that, and I'm excluding that, and I'm doing this and I'm doing that. That's what you're explaining it. So if I ask for what the query does, I expect 1 or 2 line simple English what the query does. Yes, this query basically is returning the name of the students living in San Jose with the GPA greater than or equal to 2.5. That's what a query does. Okay. When I say explain the query, then you say, okay, in this query, I'm joining student and this other table, and then I'm excluding this other rows, and then I'm doing that to be able to, let's say, for example, return these students who live in San Jose with a GPA of 2.5 and whatnot. Be able to evaluate the general evaluation strategy that we've talked about. You need to be able to, I'm not going to ask you, hey, tell me what the evaluation strategy is in the exam. Obviously, everyone would know that, right? But I may give you a query, and then I will ask you to evaluate it. And this query could be a simple query, could be a more complex query, like group by having, and so on. Similar to the way we did it in the class. Okay. Take into account the syntax of SQL query, right? Select distinct target list from relation list where qualification, group by, grouping list, having, group, qualification. Now, a few things. Syntax is extremely important. If you go ahead, and I see that once in a while, if you go ahead and define an attribute in the grouping list, and then you don't put it in the target list, we said that in the class, automatic point deduction. Your query is invalid. You know that by now, right? You've done homework number 3. If you define a grouping list, that grouping list must be in the target list, right? Or if you don't have group by and having, and then you will go ahead and combine your target list with an aggregate operator, that's a no-no. We said if you're not using group by and having, then your target list must only contain aggregate operator, nothing else. Now, if someone doesn't use group by and having, and then combines an aggregate operator with another attribute, point deduction. Okay, that will be a lot of point deduction there because that person did not even understood how to write a query in that case. Okay, so take that into account. That I will be checking these things in your queries. Okay, making sure that those guidelines that we have. I mean, if you miss a semicolon, I'm fine with that. Okay, but if you define a grouping list here and then that grouping list is missed from the target list, definitely a point deduction. Okay, so that's about the syntax. Take that into account. Now, the syntax is also very simple in the case of writing a query. I mean, there's not many components involved in a select statement. Okay, so it's just one form. It's only have a few clauses, so it's not like that I forgot something. I mean, it's only 5. How many clauses? 5 clauses here total, or 4 clauses here maximum. Set manipulation construct: union, intersect, and except. Something that I've noticed that students forget is that duplicates are removed. Okay, so duplicates, take that into consideration, that union, intersect, and except, they will remove duplicates. Okay, if you want to retain duplicates, union all, intersect all, except. Except is the same as minus. Minus is the Oracle version of it. Okay, for example, Postgres SQL uses except, Oracle uses minus. Yes, except is the same as minus. Can even fix that here. Let me add that. Not a fix, I'll just add it here. Except slash minus. Here, when I'll update it on okay. Remember that duplicates are removed. Okay, if you want to retain duplicates, union all, intersect all, and except or minus all. Questions? Any questions? Okay. No, stop share. So, reminding you guys for SQL, nested queries, right? In and not in, okay? Correlated nested queries, exists and not exist. Any and all operators, aggregated operators, count, sum, min, max, average, and so on, okay? As I did say earlier, I may define how to write the query. I may say write the query using in or exist or using set manipulation construct. So if I ask that, I expect you guys to write it the way I'm asking. Okay. If I don't ask that, then you can choose how to write it. But then you have to take into account efficiency in that case. I don't want you to join all the tables in the world without thinking what exact tables are needed. Or if, let's say, for example, there's a better solution using nested queries, I expect you guys to be able to use that better solution. That sense. SQL, we've talked about views, okay? How you can write views. Again, one thing to take into account with regard to views is that they store definition. They act like relations, but they only store definitions, okay? They only store definition. You're not storing any tables. That by itself provides some advantages to you because it will be dynamic. If your tables have been updated, the moment you execute the view, you will basically get the updated results. Now, we did also talk about how you could store the output of a query into tables. Now, one thing here is that, yes, if you store the output of a query and your original tables are updated, this stored table might no longer be in sync with those updated results. So take that into account as well. Whereas in the case of view, it would all be the moment you execute, it will take in the latest, greatest data to execute that particular query. So there are some advantages here. Table constraints we've talked about, right? Table constraints, one thing you guys should take into account is that they're single table only. That will apply to a single table. Primary key is a single table constraint. You define a primary key with a single table, or unique, or check, or not null, and so on. If you are being asked to write a particular constraint that involves multiple tables, then you will have to create an assertion. And then within an assertion, then you can use the check. With the assertion, you need to take into account, yes, someone may say, hey, can I use assertion? And then that's the question. Can I use assertion only with one table? What do you guys think? If you only have a single table, or your constraint involves only a single table, would you be using a table constraint or assertion? I mean, assertion certainly is doable, but would I use an assertion if I have a single table only constraint? That could be an exam question. Any thoughts? Any thoughts? Doable? Yes. But is it efficient? Nobody? We had talked about it. So you should know the answer. Well, it's not efficient. So if you have one single table, it's not efficient. Why? Because as we said, every time your database is updated, the whole assertion will get evaluated. Okay? So it's not efficient at all. Not efficient. No. And remember, we are saying every time the database is updated. I'm not talking about the tables involved in that assertion. Every time the database. So there might be something else being updated, but this assertion may get evaluated because the DBMS knows that this assertion has a constraint regarding that other table or not. So any update to the database as a whole will cause the assertion to get reevaluated. Take that into account. So if you have a single table only constraint, assertion, while doable, is not an optimal solution. But if you have a constraint with multiple, then you must go with assertion. You have no other choice. Questions here? Partial points depends on the question. Some questions may have partial points, some questions may not have. In general, the answer is yes, but it depends on the question. I mean, if you have a true false, of course, there's no partial. So it depends on the question. But yes, some questions will have partial points, some questions may not. Now, with regards to, okay, going back, any questions on SQL? Okay, now relational algebra. We talked about relational algebra. We've basically stated that there is selection, projection, rename, joins. There are different types of joins: inner join, natural join, theta join, outer join, etc. Talked about set operations, union, intersect, and difference. The type of questions here, you may be asked to write a query using relational algebra format. Instead of using SQL, you may be asked to write in relational algebra format. You may be asked to explain what a query does in simple English, or you may be asked to evaluate a particular relational algebra query. I mean, evaluating a relational algebra query is very simple, is similar to an SQL query. You need to understand the notation of a relational algebra in that case. Okay, so one thing comes into play, explaining the query and evaluating it is extremely is more or less the same as the SQL evaluation. What comes into play here is you understanding the array relational algebra notational format. That's basically the key point. If you understand it, explaining it and evaluating it is the same as SQL. No difference there. So that's about relational. Evaluation steps. Okay, I've been talking about that. Evaluation steps. Cross product if you have more than one table. Okay. Apply qualification and eliminate rows not matching qualification. This is the qualification in the where clause. Eliminate unnecessary attributes not in the target list. Okay. Now, if you have group by and having, then you will partition the remaining tuples in groups defined by the grouping list, and then apply having condition to eliminate the groups. I've gone over this in the class multiple times, right? If you have forgotten, go ahead and revisit those recordings. The thing is that we have these recordings. Go ahead and revisit those recordings, okay? And walk through that and then understand that. One thing that is key for the exam is that you need to basically practice, okay? Exam is not a time for you to start practicing for the first time, okay? So expectation is that you have practiced these ahead. So when you see the question in the exam, you know what to do. So you should be doing this evaluation prior to coming in and sitting in the exam, okay? The evaluation step, everyone knows, right? Everyone has memorized it. Everyone knows. But going through that is the important part. You need to understand, and if I ask you guys, you should be able to quickly go through the evaluation step and then come up with the answer. That's the key point here. Practicing is the key here. Questions? Okay. So I have done more or less a overall high level brain dump, my brain dump of what we have talked about from the beginning of the class till the end of session on Thursday, yesterday's session. So that's the key here. That's the key for you guys to be able to again go through these and be able to apply the knowledge that we have talked about. Now, as I did say, there are 15 or 16 type questions. You know at the high level the type of questions. There will be a true, false, multiple choice short answer. There will be an ER question, right? Mapping of an ER. There will be a mapping, meaning getting a scenario and producing an ER or ER diagram. There will be a question to map that ER to schema and then maybe produce SQL, DDL, create table statements. Okay. There will be a question with regard to SQL queries, writing of SQL queries, right? Evaluating these SQL queries, explaining what these SQL queries are, or I may include relational algebra as well as part of that particular question as well. So these are the high-level type of question. These questions could have parts. These questions could have parts. The true, false, multiple choice. Of course, there will be multiple of those. For the case of, let's say, SQL query, there will be multiple SQL queries that you may have to write. So, okay, so take that into account. So nothing outside of what we have talked about. Make sure that you have gone through all the slides that we have talked about in the class. Make sure you have visited the assignments. Make sure you have looked at the exercises that I've been posting, okay, on those lecture folders on Canvas. The solutions are given. So make sure you go over that, practice them, okay, and then come to the exam and prepare. Nothing outside of what we have talked about. That I guarantee. Any other questions? Okay, declaring the keys. So we did say there's primary key or unique key, right? Primary key does not allow null. Unique allows null. Okay, so that's the difference between primary key and unique. Now, when you guys define your table statements, okay, you need to indicate if it's a strong entity, you need to indicate a primary key, right? So in this case, I'm creating a table employee, right? Create table employee. SSN is of type integer, and SSN is a primary key. Now, you know that we can define the primary key in line, okay, like the first case here, or you could use the primary key clause, okay? Specifically, you must use a primary key clause if your primary key is composite, okay? If your primary key contains multiple attributes, So take that into account. For primary keys that has a single attribute, either you could use it in line or use the primary key clause. But if you have multiple attribute primary keys, that you must use the primary key clause. You cannot do it in line. That's the important part. Foreign key, right? In this particular case, I have two tables, an employee table and a department table, right? Employee table has employee name, department number, and salary. And department table has department number, department name, and manager, right? So in this case, in the case of an employee table, right, this DNO is a foreign key mapping to the DNO of the department, So that's a foreign key. So when I go ahead and create my employee table, here you go, create table employee, SSN int, name char 11, DNO int, references the department table. This is the department table, okay? Department number. Okay, so take that into account. References, department. This is the case where this name matches this name. So you could write in this format. If the name doesn't match, okay, so then you will have to use it in this format. Foreign key, DNO, okay, of the employee table, references department tables, department number. This is assuming that department table has this particular field department number, okay? So in this case, you could have a different attribute name compared to what, you know, the department table has. So take into account that you can allow multiple attributes in one foreign key constraint and allow multiple foreign key constraints in one. You could do that, especially when you have these relationships, right? Relationships might have multiple, might have or will have, at the minimum you have a binary relationship, so there will be two foreign keys at the minimum, okay? In the case of an n-ary relationship, then you will have n. Foreign key references primary key of the other table. So in this case, right, that I have these two tables, employee name, department number. Yes, there's a question.
Professor, I have a question. Can you please go to last slide, please? So here you said like we have to use same name, like
no, you don't have to. You don't have to. What I'm trying to say is you have a choice, okay? Either you can use the same name like here, okay, or you don't have to, okay? So the name that you have in this particular table could be different than the primary key of the other table that you're pointing to. This example shows a case where it's different. In this case, foreign key in my emp would be DNO, but in my department table could be department hash, could be department number, okay, like this. Okay. So it doesn't have to.
And does the case sensitivity works here because it's DNO and this is a small DNO?
No, it's not case sensitive. It's not case sensitive.
Okay. Thank you.
Okay. So now, when you have such a case with regards to these tables, this is your employee table and this is your department table. Okay. Employee table has e-name, department number, salary. Okay. And then you have department, DNO, department name, and manager. Okay. So this employee name, in this case, as you would see again, DNO is that is that foreign key. Okay. Pointing to this particular department number. Now, when you are being asked to write the SQL DDL statements, right? Make sure that you specify the actions, okay, for delete and update, on delete, on update, okay? On delete, on update, okay? That you need to specify. The default case is reject or no action, reject or no action, okay? Cascade allows you to change the employee tuple correspondingly and then either delete it in the department or update in the department. So for example, let's say in this case, you go ahead and delete a particular tuple. Let's say, for example, we go ahead and delete this tuple here, okay? Then it will cascade that deletion into this 222. This particular row also will be deleted. Default is no action. That means that it will reject this deletion and says, hey, you will have to deal with the department first, and then you can do the deletion in this case. So that's one thing. So in this case, right, when you have the department, and now for the case of an update, now let's say, for example, in the department, this 222, we change it to 444, right? This is for the case of one update. If it changes to 444, Cascade will go ahead and update this 222 to 444. Default case is rejection. It will say, no, go ahead and fix that in set, let's say, for example, your employee to, let's say, set default or null first, okay? Then you can change it to 444, and then you can go back and change it in your employee. That you could do, okay? That's the reject case or no action. Or if you do cascade, then you change this to 444 and it will be updated here. Same thing for delete. If you delete, for example, this row in the department, then it will be updated in the parent table as well. Okay, so that's again the cascade case. Oracle do not have on update, correct? Okay, but again, we are talking about the generic case. We are not talking about, the course is not about Oracle. Okay, whatever we are talking about is about, you know, SQL standard. So we've talked about on update and on delete as well, because I mean, tomorrow in your job you may be using a different, you know, DBMS. In the exam, I assume in the exam you're not assuming that Oracle is being used. Okay, in the exam you're going based on the slides. So in the exam, if I'm asking you guys, hey, go ahead and define the constraint, you will have to define the on delete and on update. Exam is not going to be Oracle specific. Any other questions? Okay, so default is the no action, reject. Cascade is that if any changes, if any deletion or update happens in the department, it will be cascaded to the employee department. And then set null or set default, okay? Set null or set default. Change the DNO value, in this case, the employee to null. So if you allow the deletion or update here, that will allow. So if I want to change this, if I want to delete this or update this, it will allow that deletion or update, but it will change this to null or a default value. Set null or, okay? Any questions here? Again, that was a good question. Okay, this is Oracle. This is not Oracle specific. Okay, we've talked about on delete, on update. So in the exam, you should basically go based on the slides. Okay, and then specify both if needed. Questions here? Okay, so just a reminder, how do we go about inserting a tuple? Okay, insert into is the syntax, and then you specify, in this case, your relation. This R is the relation, right? And then the attributes of that particular relation, and then the values, the corresponding value. In this case, insert into employee, e-name, department number, salary, values, Tom, 1, 2, 3, 25,000. Okay. You can drop attribute names. So in this case, you would do insert into employee without any attribute name. But then you need to make sure that all of these attributes are provided in the values section and in order. And then if you don't provide an attribute, a particular attribute that will be filled with, no, take that into account as well. Now, it is very important. You need to understand the insertions, because if you don't do the insertions properly, because again, in the question that I may ask you guys to map the ER, in this case to relational model, and you may go ahead and create these table statements, I may ask you guys to insert data into it, right? Now, this would be extremely important because you need to take into account the integrity constraints. So if, let's say, for example, you have an insert statement and then your primary key is, let's say, department number, okay, and then you use two insert statements with the same department number, the second insert statement will be rejected because of the primary key constraint. Okay. Or for example, if you attempt to go ahead and delete a particular, let's say, tuple from a table, and there's a foreign key business there, and then your action is, let's say, no action, that deletion might get rejected. So you need to take into account all those scenarios. Right? So you have to basically be mindful of integrity constraints where you're inserting or modifying or deleting records from. the tables, to be very mindful of those integrity. Now, we did talk about that in the class. When you do an insert into a relation, you could embed a subquery inside it. So you could have nested subquery inside your insert into statement as well. We did talk about that, right? Create table, low income employee. I'm creating a table. You have e-name, which is chart 12, department number, which is of type int, and then salary, which is also of type float. So I'm creating this table with 3 attributes: e-name, DNO, sal. And then I'm inserting into this particular table, but look, I have an embedded query. I have a subquery here. But the select star from employee where sal is less than or equal to 30K and DNO equals 1, 2, 3, right? Returns from the employee table a relation here. So that will return a relation here. Okay. Now this relation has 3 columns. This relation has 3 columns. Right? You remember the employee department has e-name, department number, and salary, right? So in this case, from employee, e-name, department, and salary will be returned. And this e-name, department, and salary, department number, and salary matches what this low-income employee expects. So I'll do select star from employee where sal is less than or equal to 30K and DNO is 1, 2, 3. So only those low-income employees whose income is less than 30K and their DNO is 1, 2, 3 will be returned and then will be inserted into this low income. That's what happens here. So select star, you can consider it as, in this case, a case where a temporary table you're creating by the select star, and then you're storing that as low income employee. You could also create these temporary tables using nested queries. You could also create them using nested queries in the from clause. We did say when we talked about nested queries, majority of the cases, the nested query is used in the where clause, right? In the where clause. But occasionally can be used in the from clause as well, okay? And when nested queries are used in the from clause of the outer query, it will create a temporary table. Because what you do in the from clause, you will go ahead and have another subquery. That subquery is similar to this case. It will basically returns a relation. That relation will be used as a temporary table for that particular outer query. That also the flexibility you get with nested queries as well. It is more efficient because in this case, you're storing it, you're inserting into a table. But in that case, it will be a temporary table. It will be in the buffer. And then once that query is done, that will be released from the buffer itself when you do it in the front. Any questions? Okay, now in this case, I want to go ahead and let's say insert into this low income employee, these employees who are low income, less than or equal to 30K with department number 1, 2, 3, and then increase their salary by 10%. Okay. So again, I do select e-name DNO, salary multiplied by 1.1 from employee where sal is less than or equal to 30K and DNO is 1. Make sense? Any questions here? Okay, we talked about how to delete from relation, right? So you need to specify optionally a where condition. That where condition in this case defines a set of tuples, and those tuples that matches this where condition, those tuples will be deleted from the relation. If you don't specify the where condition, which is optional, then all tuples will be deleted. That means that your table will exist, but the table will be empty. There will be no data in the table itself. The table will be completely. You could also embed. You could also have nested queries inside a delete statement. Delete from employee as employee 1. This is from the slides. Where not exist, and then you will have your inner query, your embedded query, your subquery. Now remember that I am renaming in this case using the range variable. We talked about update. Again, update. What it does is you could update tuples, right? Set of tuples based on a where clause, right? Change employee in department 1 to 3 into department 3, 4, 5. The department number changes. Okay. So we will do update employees, set DNO to 3, 4, 5, where DNO is 1, 2, 3. So we are changing it from 1, 2, 3 to 3, 4, 5. Or in this case, we are updating the employees and then we would want to cut their salaries, okay, by 10% if they make more than 100K. Update employee, set sal by 0.9, where sal is greater than 100K. You could update multiple things, okay, with one SQL command. You could basically have multiple assignments separated by commas, okay? Set DNO equals 3, 4, 5 and sal equals sal times 1.1. That you could do also. Okay, this choosing of the policy is extremely important. So I expect, okay, on delete and on update to be defined, right? Add on delete, on update, cascade, set null, whatever it is when declaring a foreign key. It's extremely important, okay? So I'm creating table employee, SSN int, name char 15, DNO integer. Foreign key, DNO references department number, and then I have my on delete and on update. They must be there when you define your referential integrity constraint or foreign key constraint. If it's not there, you will get a point deduction. If one of them is there, you will get point deduction. Now, of course, you need to look at the application, you need to look at the use case, you need to understand the requirement to be able to define the action properly. Attribute-based checks, we've talked about that, right? If, let's say, for example, in the requirement says, gender must be female or male, or age has to be between 18 and 100, right? So you need to make sure that you have attribute-based checks, right? So here you go, gender char 1, check gender, let's say, for example, in this case being F or M or other, whatever constraint you have, whatever requirement you have. Yes, foreign keys should have on delete and on update. That's what we're saying here, right? So you need to have to define the actions. You need to choose a policy. If you don't have, okay, again, point deduction. Or for example, for the case of age, we do age int, check age greater than 18 and age is less than 100. So make sure if the requirement calls for it, have attribute-based checks. If in my requirement, I said you have this employee and the employee name must be between 18 and 100, okay, you need to have this check. Again, you don't have it, point deduction. Assertions, extremely important topic as well, we've talked about. You are, in this particular case, going to be able to define constraints on multiple tables. The format is create assertion, name of the assertion, and then check condition, okay? Take that into account. You can drop an assertion using a drop command, by the way. I mean, if for any create command, you will have a drop command associated with it where you can, I don't even have to say it going forward. If you're using any object creation using a create command, create SQL command, then there is a corresponding drop SQL command to drop it. Okay, this drop table, there will be drop function, there will be drop assertion, and so drop trigger, etc., etc. An assertion must always be true at transaction boundaries. Any modification that causes it to become false would cause a rejection of that particular update, Now, again, take into account that assertion has performance impact, okay? And the performance impact is because of the fact that every assertion you have will be evaluated when your database is updated. I'm saying when the database is updated. So the question that I had asked earlier, which may be an exam question, okay? Now, of course, it won't be because I have said it, but at some point, hey, can I create an assertion for a single table only constraint? Yes, you can, but it is extremely inefficient. Instead, you have to use a table constraint, right, in that case. But if you have multiple tables, then you must use assertion. So here you go. In this case, I have these two tables, department number and manager, employee, name and salary. And then I want to have this constraint. Each manager must make more than 50K. So I'm going to have an assertion here, create assertion, rich manager, check, okay? And then I have not exist. I have an embedded query. Select star from department, employee, where emp.name equals department.manager and emp.salary is less than 50. So when would this check? Insert or update on tables, right? If let's say I insert something into Tom or employee. Okay, so take that into account. If I insert, let's say Tom, 40,000, right, into employee, that will be rejected. That will be rejected in this case. Okay, any questions? Questions, guys? Different constraint types, okay? There's attribute check, there's tuple check, there's assertions. Attribute check is declared with attribute, okay? Is activated when you insert update on the attribute, and it's not guaranteed to hold if it contains subquery because it will be dependent on that particular subquery. What happens if that particular subquery returns null? Take that into account. So it may not hold if it contains a subquery. Tuple check, okay? It's basically declared at the relational schema level. It basically gets activated when you will insert or update to a relation. And again, it will not be, it's not guaranteed to hold if it contains a subquery because that subquery may return null. Okay. Now, assertion is at the database schema level, and that's why I say when the database is updated. Any change on any relation activates it. Now, that relation may not be even relevant to the assertion, okay? But hey, DBMS does not know. Therefore, any change to the database, any change to any relations cause to all assertions to be activated. Okay, that's where we said could be an actual, let's say, performance degradation. And it's always guaranteed to hold. Yes, it has a cost of performance degradation, but it's always guaranteed to hold. That's about. Let's see what the time is. Okay, so we have a few more slides. Yeah, okay, so let's finish this and go for a quick break. We did say that you could define constraints in a table and you could give names to these constraints. So for example, when you have an age check, you could give it a constraint. So age int constraint right age, and then you will do check. Age is between 18 and 100. Now, advantage of this is that you could change the constraints. You could drop the constraint. At some point in time, you will come back and say, hey, I don't need to have this age check. I mean, I want to allow any check. Maybe someone has a 1,000-year age. Okay, I want to allow it, right? So you can drop it. You could drop constraints. There's a drop constraint. Or let's say at some point, you have this constraint. You could also define primary key as a constraint as well, or foreign key as a constraint as well. So SSN int constraint SSN is key primary key. You could drop it. You could drop that particular constraint, because tomorrow you may come back and, oh yeah, I no longer want to have SSN as my key. I want to have student ID, for example, or employee ID as the key. I may have a SSN and I may have an employee ID. I want to have primary key to be employee ID rather than SSN, because there might be a possibility that some person does not have an SSN. SSN could be null in your scenario. Especially in the case of a student, there might be foreign students who may not have an SSN yet. Okay, they may have student ID, but they don't have a SSN. In that case, SSN will not be a good primary key in that case. It could be student ID. So initially, we have thought about SSN, but then now we have this database that contains all records about students, but then we realize SSN is not a good primary key. So all we can do is we can just drop that constraint and then, add another constraint. You could add the constraint afterward. So using constraint gives you more flexibility, because you could drop them, you could modify them, you could add them later on. Let's say, for example, you forgot to add an age check for the age attribute at the time of creating your tables, and then you have now you have a table full of records, and then you realize, oh, I should have added a check. You could just go ahead and add a constraint at that time. Okay, so it's always a flexibility by having names for these constraints, because you could alter them, modify them later. And then again, a reminder. Any question here? Okay, a reminder on the SQL syntax: select distinct is optional, target list, from relation list, where qualification, group by grouping list, having group. Let's talk about this again. A reminder: examples of union, intersect, except. We've seen examples. Again, this is another one. I have two queries here, right? Two independent queries. The first query returns supplier ID, supplier names from suppliers where supplier ID is greater than 2000. And then I have the second query that returns company ID and company name. See, the name of these queries are different. No problem. We did not have any constraint on the name. We said their domain has to match and their order, okay? And the number of attributes. So it has the same number of attributes. The order is the same and their IDs match. Okay, so in this case, it's basically union compatible. We didn't have any constraint that says these names should match. Okay, only their data type, number of domains, and their order. Okay, folks, let's take a quick break. Any questions? May I pause the recording? Let me pull up the sample midterm. Well, the sample midterm is there already posted. Solution is given. Hold on a minute. Solution is given, and why is it showing up like this? Where is going on here? Okay, now it's good. Okay, so there are a few questions here as an example that you can see the type of question that will come up. So here are, let's say, some true false questions. A weak entity set can participate in more than one relationships. The answer is true. Okay. Again, about the conceptual aspect of the course. If we define a foreign key in relation R, the DBMS checks the foreign key constraint whenever a tuple in R is deleted. Okay, that's false. That basically comes into play when you have the action basically defined, on delete action or on update action. You could define a foreign key without specifying on delete or on object. A weak entity set must have derived attribute. Okay, that's true. Might have derived attribute. That's true. I mean, I may have derived attribute in this. ER diagram are used to model the physical schema of a database. That's fine. It's used to model the logical schema of a database. An entity set E can be associated with a relationship set R more than once. True. Okay. In the where clause of an SQL query, the condition Smith equals null is evaluated to be false. That's false in this case. If we define a foreign key in relation R, The DBMS checks the foreign key constant whenever a tuple R is deleted. That's also. Okay, so again, similar questions, true, false, multiple choice, or short. Now, what I want to focus on is this ER. So you will get a similar question, okay? And I will basically, we have about 25 minutes. That should be sufficient. I will go over how you guys can go over and produce ER or ER, which you guys have to know this already, okay? So a scenario is given. I have 7 points here, and then the question basically asks, draw a ER or ER diagram to show the conceptual design of the database, okay? It says indicate all subclasses, relationships, relationship cardinalities, okay? Total participation, partial participation, type of attributes, primary keys if necessary. In addition, specify whether each attribute is single valued, okay, or multi-valued, Doro derived, atomic or composite, okay? And then any assumption you have, make sure you take it. Okay, so let's go about designing this particular schema here. So I will start, and as you guys remember, I told you guys this before, we will go ahead and start looking at this bullet by bullet or line by line or scenario by scenario. In this case, number 1 says the company has many departments. Each department has its name and a unique department ID. That's what the question is. So the way I do this is that I will have a company as an entity here, and this company has a name, okay? Company name, and this company is associated with the department, okay? There is a department name, and then there is a department ID, okay? The company has many departments. Every department has its name and a unique department ID, which we have defined. 2, there are teams associated with each department. Each team has its name, team ID, and office location. So again, I come back here. Then there are these teams. There is a team here, okay? Team is associated with the department. The team has a team ID, a team name, and office locations, okay? That indicates that is multi-valued attribute and is indicated as a multi-valued attribute. Now, teams are associated with each department. It says associated with each department. Every team has its name, team ID, and office locations. Okay, it's multiple. So I may have a team. This team could be distributed across multiple offices. Now, the constraint: the team belongs to a department. You cannot have a team without a department. There is a total participation involved here, right? And you would see that I have total participation here between team and the department. So there's total participation. The team belongs to the department. So this line is total participation, okay? And it's one to many. There's an arrow pointing to the department. That basically team belongs to a department, okay? So there is total participation. However, the other side, department does not have to be in total participation with a team. I could have a department that does not have a team. I could have that, okay? So team is in a total participation with the department. Again, I move forward and I read now the 3rd point. Every team has its employees. Okay? Employees could be associated with multiple teams here. Okay, every team has employees, and employees could be associated with multiple teams. So now I have an employee. Okay, employee has a team, and it's many to many because team can have many employees, and employee could have many teams. So it's a many to many relation. Every team has employees. Employee could be associated with multiple teams. Okay, employees, number 4. Employees have such information as unique company-wide employee ID, a company email address, personal email address, home address, start time, and cell phone number. So I have, in this case, employee. The employee has an employee ID, a company-wide employee ID, has a home address, has an email, has multiple phones. So it's in this case is a multi-valued attribute, multiple personal emails, multi-valued attribute, and a start time when this particular employee has joined the department, started with this particular, let's say, location. Now, employee should belong to one of 3 employee types: full-time employee, part-time employee, and intern. Okay, so looking here, then employee in this case would be my superclass, right? And then I have these employee types: full-time employee, part-time employee, and intern. So can I have an overlap here or disjoint? This would be disjoint. See, I have to define, in this case, the constraint. Okay, so a full-time employee and part-time employee, they're disjoint. Okay, part-time or full-time employee and intern are also disjoint. Either I can be full-time employee or part-time employee or intern. Okay, so this would be disjoint. Disjoint overlap, this definitely would be disjoint. Now, if it is total participation or partial participation, so in this case, the requirement stated that it's only these 3 employee types: full-time, part-time, and nothing more. Okay, therefore this is full participation. So this is double line. So your employee are either full-time, part-time, and there's no other ones. If there were like any other ones, then it would have been a single line, partial participation. But in this case, because we stated that it's only these 3 types: full-time, part-time, and intern, then it's total participation and it's double. Question so far? Okay. How come the department isn't total participation or one-to-one? Let me take a look at, in this case, the company has many departments. Yeah, I can fix that. That's a good point. The company has to be one-to-many and it should be total participation. Exactly. I should have this line as bold with an arrow pointing to the company. That's basically a small error here. I'll fix that right after. Okay, good point. Any other questions? Okay, so let's continue. Any questions? Any other questions? Should teams also have? No, it doesn't have to be. Meaning we didn't, I mean, there could be employees. I mean, let's say, for example, a company would, first of all, it's not clear in the requirements, so it shouldn't be. But there are companies, let's say, for example, you get hired, but you're not assigned a team. Okay, I mean, different companies do this differently. I mean, one company, you go from day one, you have to be assigned to a team. In that case, yes, there is total participation. There are companies who may hire you and then they send you to some boot camp and say, okay, you go ahead and get trained here for 1, 2, 3 months, and then we will figure out a team for you. Right? So in that case, it's not necessary. And team require. No, you may have a team, but this team has established but doesn't have anyone. It could be a case that you have a team, meaning it could be a scenario, but it's not in my requirement. That's what I'm trying to say. What you're saying could be true. What you're saying could be true. I'm not saying that what you're saying is wrong. What I'm saying is such a scenario that you're saying is not in my requirements. But if it was, yes, what you're saying is absolutely true. If there's a case that says, employee must have a team or team must have an employee, then that scenario could be captured with total participation, definitely. But these are all good questions. Any other questions? Okay, so let's move forward. So employees should belong to one of the 3 employee types: full-time, part-time, and intern. We've talked about that. Full-time employees and part-time employees have insurance policy information, okay? While interns do not have such information. Insurance policies belong to so again, full-time employees and part-time employees have insurance policy information, while interns do not have such information. Okay. Insurance policies contains policy number that is used to identify the policy and content of the policy. So here I will have an entity insurance. Okay. And we basically say that both full-time and part-time employee have insurance. So again, as you see, both full-time and part-time employee are in connection with a relationship called has, and has is basically connected to the insurance. And insurance has an insurance number and content. So that's for this case. I'll get back to this ternary relationship in a moment. So we have decided at this time to represent that using a ternary relationship. So full-time employee and part-time employee have insurance policy information, while interns do not have such information. Insurance policies contains policy number that is used to identify the policy and content of the policy. Okay, that we have indicated. And then you have part-time employees and interns have to fill out timesheets to record their working time. A timesheet contains records of start time and end time. Full-time employees do not need to fill out such timesheet. So again, now I have timesheet here. Okay. Part-time employee and interns have to fill out the timesheet. Okay, I will get to the constraints in a moment. And then the timesheet has a start time and an end time. Okay, and start time could basically be year, month, and day, and so on. Okay, so we have represented that. Now let's go back to number 6, where we said full-time and part-time employees have insurance policy information, while interns do not have such information. Insurance policies contain a policy number that is used to identify the policy and the content of it. I come back here and I look that we have represented using the ternary relationship. So again, we've talked about this insurance business before. Insurance, in this case, belongs to full-time and part-time employee. That's what we're saying. So there is total participation. But my question here in this case is, should I go ahead and reduce this to multiple binary relationship, or a ternary relationship would work here? What are your thoughts? Would a ternary relationship work here? I mean, we did say that when we have a ternary or n-ary relationship, when in general we define some sort of a constraint, that will cause ambiguity. And then we have to go ahead and reduce that to multiple binary relationships. That's what we said. So now the question here is, I have these three entities, full-time, part-time, and insurance. And then I need to have this total participation here for insurance, because insurance is in total participation with full-time employee and part-time employee. Now, is this a right representation, or I have to break this down, reduce this to multiple binary relationships? Is there any ambiguity here? Thoughts? This relationship representation is totally fine. Okay. We basically did say in the past that if I have a bold line here, or I have an arrow here, right, the ambiguity comes into place where we don't know this total participation belongs to this full-time or part-time. But in this scenario, there's no ambiguity here, because insurance is in total participation with both full-time and part-time employee. Okay. So in this particular case, in fact, this representation is absolutely fine, because there is no ambiguity. There is no ambiguity. So we can represent this as a ternary relationship as is. We don't have to break this down into multiple binary relations. Now, same thing with the timesheet. First of all, the timesheet based on, see, it says a timesheet record their working time. A timesheet contains a record of start time and end time. Okay, so I have the start time and end time. And then neither of these or combination of them could be, in this case, could indicate a primary. So timesheet is basically a weak entity. So this is bold, right? As we said, this is bold. And in this case, we will this bold rectangle indicate that this is a weak entity. And then we will make this particular relationship, okay, that connects this weak entity to the identifying owners as bold. That also we are indicating. Now, identifying owner for the timesheet would be part-time employee and intern. Okay, it could be this one and this one. If the part-time employee is filling out the timesheet, the part-time employee would be, in this case, the identifying owner. If it's the intern, then it will be the intern being the identifying owner. So again, in this particular case, a ternary relationship would work fine. Okay, total participation that this particular timesheet has, total participation of one to many, again points to both part-time and intern. So again, there is no ambiguity in this particular case with regards to this particular weak entity. So that also in this case is correct represent. No need in either of these cases to go ahead and reduce this to multiple binary relationships. So that is not needed. Now there is one thing dropped here, which I will add right after, the partial key. Okay, the partial key could be start time or start time and end time together. That could be the partial key. So I will underline start time right after, and then I'll re-upload the sample midterms. Okay, so that's that. Any questions? So again, I did, and you get a similar one, maybe even the question that you will get maybe even smaller than this. Okay, I went line by line and represent that. Okay, the question you will get is definitely going to be smaller than this. But again, the concept is the same. You will be given a scenario, you have to produce an ER diagram. So all these constraints that you're seeing here, you have to map that properly. Okay, take that into. Okay, any questions? Any other questions? Any questions, folks? Okay, so let's continue. I don't have a lot of time left. So what I'll do basically is to go over the next question. I mean, the solutions are given. So in the next solution, basically the next question, part B of this particular question, then it's asking you to map your conceptual design to pure relational model. In this case, I'm saying no SQL definition is required. Okay, so you basically define the schema. You go ahead and define the schema. Okay, in the notation that is defined in the class. Right? Mapping the primary keys, foreign keys, and so on. So if the question says, SQL definition required, then I would require create table statements, right? So in this case, no SQL definition required. Therefore, you just go ahead and define the scheme. And then the next question is that it is the SQL question. Okay, so in this case, consider the following schema. So it gives you the schema. Okay, and then in the table, company year founded stands for the year the company is founded. The hire stats table records the statistics of the hiring for each company. Company name and hire stat is a foreign key which references the table company. Okay, number of new hire is not null and is always a positive number. See, these are all constraints that I'm specifying here. Then it is basically asking you create two tables require constraints. Okay, create table company, right? Company name is char255. Year founded is of type integer, not null. Primary key is company name. And I have create table hire stat. Company name is char255. Number of new hire integer. Primary key in this case is company name, comma year, and then I have foreign key, right? Company name, references company, on delete cascade, on update cascade. And then I have check because we said the number of new hires is always positive. Number of new hires is greater than 0. Okay, so I have created the constraint is given, and then you're creating these tables corresponding to the so foreign key is defined, primary key is defined, foreign key has the associated actions, both on delete and on update, as I did say, and then the check constraint. And then I have these queries, as I did state, right, that you may have to write these queries. Find the average hiring number for company name Apple between year 2011 and 2012, okay? Or find the company names that were founded between 2000 and hire more than 60 people in 2020, okay? Or find the total number of people hired for each company since it was founded. So again, as you would see, these type of queries that I have here, I don't have any restrictions in terms of how you write it, okay? But again, you're writing your query that you're writing, obviously, you need to make sure that that is proper, it's optimal, okay, in that sense. But again, I may say, okay, write the query using in keyword or not in keyword or exist keyword, or write it using intersection or union and so on. So I may be very prescriptive in terms of how you would go about writing. Okay, so that's that. So I went over everything I wanted to. We have about 3 minutes. Any questions from you guys? Stop the recording.